I make electronic devices, and one thing that I'm really interested in doing is trying to get away from electronic devices that you might be familiar with, so the kind of silicon chips that are inside your mobile phone or inside your laptop computer. You know, when you see these, if you've ever opened up your computer or seen inside one of these devices, they're made out of this very brittle material, out of silicon, and it's brittle and it's also relatively expensive. Now, what I want to do is I want to make electronic devices with good performance, so things that work really well, but make them on flexible kind of platforms, so you know, on a plastic film or directly onto fabric or a piece of paper, something like this. So I look at growing nanowires. So a nanowire is just, you know, as you imagine, it's very, very, very tiny wire. It's like cooking spaghetti. So we take our piece of plastic film or a piece of fabric, whatever it is that we're growing on, and we put it into a bottle of water, and then we mix in the chemicals that are going to grow the nanowire, and we heat it up to around 100 degrees, so exactly like cooking spaghetti. And then we find that our nanowires will grow exactly where we want them to on the plastic film. They grow along, and we're able to then use them as an electronic device. One of the big pushes for these types of flexible or stretchy devices is that you have this wire, very, very small wire, and it interacts a lot with the surrounding environment. So you might want to take a sample of water and find out, is there some contaminant in my water, you know, and things like this. So we need to make our devices robust, but we need to be able to run them in a liquid. And we've actually been able to do this. We've been able to grow our wires where we want them on a flexible film that we can pick up, and we can you know, move it around, and we can then operate it in liquids, just simply in water.